Okay, that's ionic bonds. Now let's move forward and continue on to discuss covalent bonds. Okay, let's start off with a definition. Okay, so covalent bonds occur between nonmetals. So only nonmetals participate in chemical bonds. And what a covalent bond is it's a chemical bond that is formed when electrons are shared. So it's a chemical bond formed when electrons are shared. Okay. Now, there's 3 types of covalent bonds. The first one is a single bond, and it's modeled or shown when we draw 2 electrons and a line between them. So this is when one pair of electrons is shared. So it shares 1 pair of electrons, and that's a single bond. The next type of covalent bond is a double bond. And in a double bond, 2 pairs of electrons are shared. Okay, and it's shown with this two lines between 2 atoms. So it shares 2 pairs of electrons. Okay, so remember, a bond is created between 2 nonmetals. Okay, so it's created again between 2 nonmetals, 2 atoms that are both nonmetals. And in this case, the 2 atoms will share 2 pairs of electrons. The third type of bond is a triple bond, and you guessed it, in this case, the 2 atoms share 3 pairs of electrons, and we model them kind of like this, where we would draw 3 lines between the 2 atoms. So when a triple bond is formed, the 2 atoms are sharing 3 pairs of electrons. All right, moving down and on to the properties of covalent bonds. Covalent bonds do not conduct electricity. They have lower melting points and lower boiling points. They do not separate in water. And they can be solid, liquid, or gas at room temperature. So they can be solid, liquid, or gas at room temperature. Okay, let's scroll down and I will show you how we can model a covalent bond being formed. So let's look at nitrogen gas. So nitrogen gas is actually a compound formed between 2 nitrogen atoms. Okay, and remember, all chemical bonds are bonds formed between interactions of valence electrons. So I like to always start with a Lewis dot structure, and nitrogen has 5 valence electrons. So I'm going to draw the Lewis dot structure of nitrogen, and as you can see, there's one pair of lone electrons that are paired up on one side. And then we have these three on each that are not paired up. And so it's actually these three electrons that are going to be shared among these two nitrogen atoms. And so all three of these lone electrons that are kind of by themselves are going to be shared between these nitrogen atoms. And what we end up with is this molecule where these three electrons from each nitrogen atom are being donated, and then these bonds are being created between the sharing of these electrons right here. And what that does is, if we look at if we count the number of valence electrons around each nitrogen atom, right, each one of these bonds counts as 2 valence electrons for each of these nitrogen atoms. And so that makes this nitrogen atom have 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. And this nitrogen atom here also has 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. And so by sharing these electrons, each nitrogen atom now has a full valence shell. All right, so that's covalent bonding. Now let's go into metallic bonding and talk a little bit about that. All right, so a metallic bond includes just metals, which you probably guessed from its name. And a metallic bond is a bond formed when many metal atoms share their pooled electrons. It's a bond formed when many metal atoms share their pooled electrons. Okay, so many metal atoms share their pooled electrons. So metallic bonds are sometimes like ionic bonds, and they're in some ways like covalent bonds. They're similar to ionic bonds because the atoms give their electrons away. So they give away their electrons. Okay, the atoms in the bond give away electrons. And they're like covalent bonds because the metals share electrons. Okay, so these are ways that they're like ionic bonds, and another way why they're like covalent bonds. So properties of metallic compounds or metals are that they have high melting points and high boiling points. Okay, now I'm just going to use MP as an abbreviation for melting point, and I'm going to use BP for an abbreviation for boiling point. So they have high melting points and they have high boiling points. They're also good conductors of electricity and heat. They're good conductors of electricity and heat. And probably the most favorite thing about metals is that they're shiny. Now, modeling this kind of looks like this. If we had a piece of an aluminum, so aluminum is Al, this circle represents the nucleus. It's positively charged. This is not an aluminum ion, it's the nucleus of an aluminum atom, and therefore it's positively charged because a nucleus has only protons and neutrons in it. Okay, so we have some positively charged nuclei of aluminum. And what happens is all of these aluminum atoms give away all of their electrons to and they pool them all together. So they create this like sea of electrons where the nuclei are just kind of floating around, if you will, in this sea of shared electrons between all of the metal atoms. Okay? So we have these positive nuclei in this sea of electrons. And this takes me back to this property here of metals that says they're good conductors of heat and electricity. Well, electricity is simply the flow of electrons, right? So that's what electricity is. And it's really interesting because metals are such good conductors of electricity, which is simply the flow of electrons. And that's because there's this sea of electrons here, right? Where they're just free electrons. And so when you hit them with energy, it moves electrons in a specific direction. And so it transfers or moves electrons through and helps move energy. And electrons are essentially energy. So really interesting. Not something you'll be assessed on, but I think it's very interesting. Anyway, those are your notes on types of chemical bonds. So please put them in your binders in your notes section.